Hello everyone, welcome back to my YouTube channel. This is Anish Kumar, and today the topic which we're going to discuss about is mathematical foundations for computing, and under that we'll be seeing the applications of curve fitting. Basically, we'll be knowing what curve fitting is, like we'll learn what curve fitting is, what are the applications in the real world, and how it can be really useful when it comes to signal processing in computer worlds and all the other related aspects. So we'll just get started. Introduction to curve fitting, applications of curve fitting, applications in daily life. So we'll just see about all these, about different applications and how they're useful to us and all that. So introduction, the process of constructing an approximate curve y equals f of x, which fit best to a given discrete set of points x of xi, yi, where I can have the values 1 to n, is called curve fitting. Basically, so many values together, if they are fixed in a certain arrangement, like yeah, whatever you can see here, like the curve is actually made here. You can see that that's a cubic curve, and there are so many other curves, but the best possible curve is chosen among these. And yeah, that's what it is. That's what curve fitting is. You actually fit the points in a given curve, and that's what curve fitting is. Various methods of curve fitting. Firstly, we check out the graphical method. Like that is the most common one. We don't need computers. It's just pen and paper. That's enough. Method of group averages, method of moments, method of least squares. We look into these one by one. So firstly, fitting of simple curve using method of least square. The method of square techniques is applied in such a way that it represents the curve of best fit. It represents the best possible constants in the equation to fit the given data. The data available is having the following relation. So linear has the equation y equals ax plus b, quadratic has y equals ax to the power b, power has the equation y equals ae to the power of b into x, parabola has the equation y equals ax square plus bx plus c. So what method of least squares actually does is you'll have many curves on a certain graph. Like there might be so many different graphs. For example, a class of students or a class of phones, or not a class of phones, a box of phones. Imagine there are 4 to 5 phones in a box, and all you have to do is choose one phone out of the box. What will you do? Obviously, the one which is the best among them. Like you'll see different properties of the phone, you'll see the basic needs like the what is the camera, the performance, the processors, and the storage and all that. So you'll see all these, and only then you'll come to a conclusion on which phone you should be taking out of the box. You can select only one, like you choose the best one. Exactly, just like that. Even here, out of all the curves there, we actually select the best possible curve or the best fit here. That's what method of least squares does. Applications of curve fitting, like you can see many applications, but I've picked a few of them. Height of dropped object versus the time wala graph, oxygen in soil versus the temperature wala graph, pore pressure versus the soil depth wala graph, profit versus the paid labor hours. Application. Curve fitting is a technique commonly used in various fields, including computer science and engineering, and other IT related fields. Curve fitting can be applied in several ways to solve different problems. So curve fitting, what it actually does is chooses the best ones. Like when it comes to signal processing as well, like so many different signals have so many different bandwidths where you can be sending the signals. But what do? You actually select the best possible bandwidth, which actually takes in the least amount of noise, and only then you actually send your signals. Like you choose the best possible bandwidth, and then you just send in the signals. Data analysis and modeling. Curve fitting is often used to analyze and model experimental or real world data. Engineers may collect data points from experiments or observations and then use curve fitting techniques to find a mathematical function or equation that best represents the data. Data analysis, like what is the data? Data is actually a collection of information. Information actually makes sense, but data doesn't make sense. Data can be anything. They can even be garbage values, which actually are useless, but even then they get accumulated in our data. So, what do we mostly do? We mostly ignore them, but what curve fitting actually does is it just ignores the garbage values and it selects the best ones out of the data, like whatever we need, what is the perfect one for us, like according to our need. It just selects it and it gives in the required data, like the best possible data, like whatever we need. Like that's what it does here. Signal processing, like whatever I told earlier, curve fitting is used in signal processing applications. For example, in digital signal processing, signals are often represented as discrete data points. Curve fitting can be employed to approximate the continuous signal from these discrete data points. This can be useful in applications such as noise reduction, signal interpolation, or signal reconstruction. So at times we might have noticed this, like when we have to send a certain signal to another person, like we are the senders and they're the receivers. We send in a signal, and whatever the receiver gets is actually faulty. Why? Because of the noise in the medium. Like whatever medium we send it in, it actually contains noise, and that actually spoils our signal. Like whatever signal we have sent, it just actually corrupts the signal, and whatever we want to send, that signal is not actually being sent to the receiver. He gets a different signal which actually contains noise, and noise, like normally humans or anyone would actually like to decrease the amount of noise in the signals that we send, because noise is like a waste value, like it just gets accumulated as we send our signal. So we have to minimize the noise. Like it's an ideal situation where a signal contains 0% of noise. It's not actually possible. Like it might be possible in future when you use high technology wale tools, but now you can't be doing it. Whatever you do, some amount of noise always gets in. So that's what curve fitting actually does. It chooses the bandwidth with the best possible signal processing, or the one which contains the least amount of noise. Image processing. Curve fitting techniques are also applied in image processing tasks. For instance, in computer vision, curve fitting can be used to extract geometric shapes. Geometric shapes include circles, square, rectangles, triangles, and many other things, and also lines or curves from an image. So in an image you can extract many different shapes, you can extract the lines, the curves, and many other things with the help of curve fitting. This process involves fitting a mathematical model to a set of image points representing the desired shape. Curve fitting, the least square method. You can see three graphs here. Firstly, the linear graph, then the quadratic graph, and the cubic graph. And you can see that the points are scattered in different shapes. Like these points have been scattered like this. Like it's a slanting line which is linear, and then we can see a quadratic line. Like what is it? A parabola? Okay, I'm not sure about it, but guess it's parabola. Like that's a quadratic curve. And finally, we have a very complex cubic curve. Like out of the three, the cubic curve is the most complex in this. Stock marketing. In today's world, stock market is trending because of its capabilities. Yesterday, a person can have nothing, and today, if the stock market gets in his favor, he can have everything. The rags to riches wala story can actually come true within a day with the help of stock market. That's how powerful stock market is. All you need to have is perfect knowledge of stock market, and just basic data should be analyzed, and then you can easily just crack the formula of being successful in the field of stock marketing. And stock marketing also uses many mathematical applications and also curve fitting. Out of all the possible stocks, so many stocks to buy and sell, and you have to choose the best ones. You just gotta give it a shot. If it's successful, then you're just a lucky person. You're just very, very lucky. And if you somehow don't get it, then yeah, you'll have to pay the consequences. So it's like a two-faced coin. It can make you like really, really, really happy, or at the same time, it can make you depressed and all that. Like, yeah, personal experience. So, okay, a stock market also uses the curve fitting application. And the softwares for curve fitting, like what are the softwares that you can use for to try out the applications of curve fitting? MATLAB, C++, C, Python, Java, Excel, R programming, and Mathematica. So out of all these, the preferred one is obviously Python. Yeah, you all might have guessed it already, because Python is a Python is like a very simple language. Out of all the languages, whatever you're seeing here, or all the softwares, whatever you're seeing, Python has a wide variety of applications, and you can use it very, very efficiently. You can also write the codes very easily because the readability is very simple in Python. A normal person can just write the basic English words when it comes to coding in Python. And yeah, these are the softwares you can be using. And yeah, whatever I told earlier, in the field of coding also, it's very, very, very useful. Like whatever logics you write, you just got to select the best possible logic out of all the available logics. So that can be done with the help of curve fitting, and then even computation is possible. So that's the difference between a normal building and a building with curve. So the normal buildings, like the ones we okay, the ones we see mostly, they're the normal buildings, pretty normal, pretty straight, no slanting stuffs and all that. But on the other side, when we see a building with curve, looks fancy. A few people probably won't like it, but yeah, it looks fancy. It looks different, different from all the buildings, whatever you see. So this is the Sydney Bridge in Australia. So it actually has this equation y equals minus 0.00188. Oh yeah, whatever the equation is. This bridge actually has that equation. Even to make a bridge, it's really, really important to follow these curve equations, or your bridge can just get dismantled within a few days or weeks, depending on how poorly the calculations have been done. So Sydney Bridge was done perfectly. As you can see, it's like a perfect one. So that's how good mathematical calculations should be if you gotta make a proper bridge. Fitting of tooth using parabola projections. So this is how it is. The placements of all the tooth, curved arcs of a metro station. Like yeah, even their curve, like curves are present everywhere. Like wherever you see, yeah, they've got curves. So this is all about curve fitting. Hope you all liked it. Don't forget to like this video and kindly subscribe to my YouTube channel. Thank you.